I'm going to go ahead and hit record. All right, everybody, we're going to be looking at specifically the prerequisites number 4 and just talking about what happens when you solve nonlinear inequalities. Now, guys, the reason why I call this one a nonlinear inequality is because what does an absolute value look like, everybody? It's like the V. That's not a line. It's kind of like two lines, but it would not be fair to just call it linear. The ones that you were working on yesterday, most of them were linear. But today, the first thing that I would choose to do is bring that 2 across, just like we talked about earlier. Now, this is the place where ultimately a lot of people make like a little bit of an error. And that is, when you see this, I want numbers that are big, don't I? It doesn't say I want this thing to be bigger than 3. So just like before, we could write it this way, but we could also come over here and write it another way, because not only should I compare it to 3, I should also compare it to -3. But here's the part that's goofy. In a sense, I just multiplied by a negative, didn't I? Because I am considering the other side of that coin. So I want it to be below -3, because think about it. What's a number lower than -3? Someone said like -4 or -10, right? But if I plugged in -10 and I took its absolute value, wouldn't that make it be big, which is exactly what I want? So I either want big positives or big negatives, so it has to be below that. So as I proceed through this problem, I divide by -2, so I want values below 0, or I want values above 6. And so how this particular problem works is I have 2 solutions that either x is below 0 or x is above 6, and that would look sort of like this, below 0 or above 6, if we were going to write it in either inequality or graphing notation. Did I mess up? It is 3. Thank you so much. Let me fix that. Thank you. I divided, but I wasn't paying attention. That's going to be a 3 there, here, and here. Good. All right. So can you guys do me a favor and check out number 2? Can you do the same thing? Now, I already did it for you in a start because your absolute value is already isolated. So I did the left side. That's the one most people are good at. Could somebody tell me what I need to do for the right side of my story? Instead of comparing it to 3, I need to compare it to -3. And instead of making it greater than or equal to, why must it be less than or equal to? Because I'm dealing with the stupid negative thing that's there, and I end up multiplying by +3. Do I need to flip that over? Nah. And then bring the 2 across, and I have this story. Now, when you draw the picture, it says above 7. It says below -11, right? You guys cool with that? Now, let's try something. Let's say you're taking a test, and your grade is 90% based on that test, and you want to make sure you didn't do something dumb. Somebody give me a number that is true according to my graph. Somebody give me a number that is true according to my graph. Like the number that jumps out at me is the number 19. Now you might like, why 19? It's because I'm lazy. Is 19 in my true region out here? Why did I pick 19? Because 19 plus 2 is 21. Oh, is 7 bigger than 3? Yay! So I think I did okay. How about, can you guys give me a number that doesn't work for certain? Like it should not work according to this graph. 6 should not work. In fact, what else doesn't work? 5 doesn't work. In fact, 1 doesn't work, does it? By the way, I picked 1. Because look what happens. What's 1 plus 2? And 3 over 3 is 1. Is 1 bigger than 3? No. So when I tried it, so why did I pick 1? Is I just tried to make something that came up with a nice, easy number. See, if it works here, it better work here. You guys okay with that? Okay. Now, what happens is a little strange in this one. By definition, now there's different approaches to this, but this is just mine. Look what it says. I want it to be less than 6, which means I don't want big numbers. What do I want? I want small numbers because I want somehow, I'm okay if they're positive or negative, but they just need to be less than 6 somehow. The way I do that problem is I don't do the little flipperoo thing, but if you pay attention, I did. See, did I leave this alone right here and write it just like it said? But then notice instead of the thing being less than 6, now all of a sudden it's greater than the negative 6. And what that does is it sandwiches it in between those two values. So what would you guys do next? Get rid of the 4. Very nice. And last but not least, we now need to move that little pesky 5 that's sitting there. And so if I add 5 to both sides, I'm looking at this. And I know a lot of people get uncomfortable because they feel like absolute values should be something like 29 and negative 29. But remember that V that you're talking about, when you move these things around, you've actually shifted that V along the x-axis, and therefore it's not going to be symmetric. By the way, in interval notation, this is our graph, but that would mean in interval notation, I could have written it in that format. I know not all of you like this format because it's kind of new, but you could have also answered this from negative infinity to negative 11 union with from where to where? 7 to positive infinity. I like this version better because it's just kind of concise. You just say left to right what happens and what is true. Okay, so I kind of checked a little bit about absolute values, okay? Now again, one of the reasons we like absolute values so much is we've talked about the fact that if you ever have the square root of x squared, you get an absolute value. I mentioned that the other day. Every time you complete the square, you're going to get a square and you're going to take a square root of both sides, which is going to pop this absolute value, which is why you get the two cases. That's one of the reasons we stress it so much. Now, all of these are not absolute values. What are they though? Those are quadratics. Now, why are these all considered quadratics? Because they all have x squared. And they're inequalities, of course, because, well, they're inequalities. This one is a little different, but we'll talk about that. So the first step when you solve a quadratic, according to what we've been talking about over the last week or so, is you always, if at all possible, want to factor. So I rigged most of these problems to be beautifully factorable because it actually helps out a little bit with the way the math plays. So what would make 21, do you think?
7.
Probably 7 and 3. And so if you just kind of look artfully, 14 and 3 would make, in fact, 17. And I want a positive 21 and I want a positive 17. So what's going to happen? There you go. So I started out by factoring. Now, some people don't like this little piece, but there's a reason on something that's coming actually starting tomorrow as a reason why I would really like to see you do that. always if you have an inequality, and sorry, Baron, always if you have an inequality, please draw me a number line. And there's a reason I'm going to go over that, because what I have found historically, when we take this to the concept that we're going to hit tomorrow, when people don't have that number line, they miss it with about 50% frequency. So where does 0 happen, everybody? Can you tell me? Where would 0 occur? What would make 0 happen in this term? -7 would. Yeah. And I can allow it to happen because it says equal, doesn't it? Where would 0 be on this one? -1.5, which I'm going to go ahead and call -3/2, but that's fine. So guys, this is what is known as the sign graph method. It's actually a really, really important thing to be aware of. Some of you guys aren't necessarily going to like it, but I can tell you if you embrace it now, it makes calculus a much easier course when you get there. See, when you deal with an inequality, if they say you may ride the ride if you're higher than 5'2", let's say that. Do they care how much higher you are? They just care, are you? See, this problem is true if you are less than 0, i.e. negative, right? Does it matter how negative? No. If you're a little bit positive, are you going to be rejected? What if you're a lot positive? Still rejected. I don't care. I just care about the sign. So this is kind of how I play the game. And then we also can go quicker. Tell me a number to the right of -3/2. And by the way, this goes all the way to infinity because I've broken the number line into 1, 2, 3 regions. 1 to the right, 1 to the left, and 1 in the middle. So give me a number out here to the right of this, knowing that it goes forever. What would be a nice, easy number to use? 0. I like it. If I plugged in 0 right here, this entity is a positive answer, isn't it? You don't have to work hard to know that's positive, right? 2 zeros plus 3, that's going to be positive. What about in here? 0 plus 7 is going to be positive. Now, what is a positive times a positive? I don't want it. That means don't go out here, right? See, I don't care that it was how big the positive is. I just know it's positive and I can't be there. Give me a number in here. Yeah, in here somewhere. -5. Now, if I try -5, -10 plus 3 is going to be some negative answer, isn't it? What about a -5 in here? It's a positive something, but a negative times a positive, what's going to happen if I have a negative times a positive? I get a negative. Is that what I want? Oh, in fact, it is exactly what I want. That's a happy spot to be. But what do you think happens when I get all the way over to the left and I try his number out here like -10? What's going to happen out here is that's going to be negative. What's that one going to be? And what do you know about the product of two negatives? It's a positive. So that's not going to work either. So the only region that is going to work is this one in the middle. This little thing that I'm doing is called the sign graph method, and it's a really helpful thing in some of the more advanced classes, and you'll see later on why we stress it so much. But what I'd like to see you guys do is see if you can do this problem right here yourself. And then we'll talk a little bit about how you could maybe make it a little quicker. See if you could factor that and come up with a good solution. That works. Okay, so what are the happy spots, everybody? Where are the places I need to think of? Where would 0 occur according to these two little factors? 2 is one of them. Can I have 2? Not supposed to have it, right? Because it says strictly less than. What's the other one? 1/4. I like it. Now, what happens if you move to the right of 2, everybody? What do you think is going to happen? Well, what would happen to the signs if you plugged in something to the right of 2, like 8 or 10 or something like that? If I plugged in 10, wouldn't this be, it would be a positive, and the product of those two positives would be positive, wouldn't it? What happens in the middle? Like if you tried 1, I'd get a positive here and a negative here. What's a positive times a negative? Ooh, that's a negative. And out here, it is the product of 2 negatives. So where do I want to be, considering the problem says I want below 0? Do I want the outsides or do I want the middle? I want the middle this time. And so that's a weird answer because we can write it this way, and remember, it looks like a coordinate, doesn't it? Oops. But that's okay. That is the correct answer in this case. What do you guys think? Is that fairly simple? Now, by the way, how many variables do you see? And there's something kind of interesting because, parent, it kind of plays into what you're doing here because you're doing a lot on Desmos, right? So how many variables are in this is just 1, right? So do you guys know that you're not really supposed to graph this on a number, like on a whole plane? Because if you have a whole plane, you have to have X's and Y's, don't you? What is there here? There's just X's. So there's no Y, there's no 2-dimensionality to the graph. But if I could pretend, by the way, pretend that it was, what kind of parabola would this be? Would it be a smiling parabola or a frowning one? Sam says it's a smiling parabola. Well, if you think about it, does this smiling parabola go right along with our sign graph method, that it was positive out here, negative in the middle, and positive out here? Do you see that in that 2-dimensional graph that shouldn't really exist, but you can kind of see it? Now, what makes this one a little tougher is, notice that cube? We suck at cubes. But the first thing you're supposed to do in all factoring problems is look for that greatest common factor. And what do these both have in common? These both have an X, don't they? So if I were to factor an X out of both of them, we have that. Now that's a little strange because when I did that, I'm still not quite down to what I had right here, but this is one of those happy little things that you guys studied, I think, back in Math 2, and you got them occasionally in Math and Algebra 2. You guys, when you factored, do you guys remember ever factoring like x squared minus 36? Yeah. What was x squared minus 36? That was like x plus 6, x minus 6. Those are like the easiest ones to do, right? What was x squared minus 49? X plus 7, x minus 8. Well, what's x squared minus 1? That's x plus 1, x minus 1. So in my sign graph method, I should have something happening at 1 from this one, -1 from this one, and 0 from this one. Those are all valid answers. And if we played the sign graph method, what would happen if I tried a number above 1? Think on this for a second. Like 6, positive, positive, positive. What is the product of 3 positives? That's positive. What do I want in this story? Look what it says. I want positive. Yay, this is good stuff out here. What about what happens in here, like if you tried a half? What's that? If I plugged in a half, isn't that positive? What's a half plus 1? Also positive. What's a half minus 1? That's negative. What is a positive times a positive times a negative? Ooh, so I don't want to be in there, right? Because didn't the problem ask specifically for the answers to be above 0? So now, what do you guys think is going to happen? This was a yes, this was a no. Any guesses in here?
Yes.
It's going to be a yes. And it turns out if you try it, you're going to get 2 negatives and 1 positive. It's a yes, it works. And then what do you think happens out here?
No.
It's going to be a no because out there, actually all 3 are negative. So my solution is everything from -1 to 0. And then what else?
Negative or 1 to.
Yeah, from 1 to infinity. So what I would like you guys to do, if you wouldn't mind, can you guys fix something? There's a typo on this thing right here. There should not have been an X right here. That was a boo-boo. Can you guys try to do a couple of these? There's on number 10, there was an extra X next to that 9. So I just used whiteout to make it go away. Yours won't maybe look quite so elegant, but can you pop in here and do maybe 1 or 2 of these? In fact, please make sure you do either number 9 or number 10 as one of the ones that you pick. So try to do 1 or 2 of them. There's the one brand that I don't like, is like pull it and it leaves this big long tag extra. This one breaks off like every time, just right. So nice. So I'm going to go ahead and pause the video for a minute because I'm giving people a little bit of time to. Okay, so we're going to go ahead and resume a little bit here. So one of the reasons I asked you to do number 9 as a possible answer is if you factor this appropriately, I want 0 and I want negatives, right? But the problem is when I do that and I try a number above 4, like 12, I get a positive times a positive, which is positive, right? What happens when I go below 4? I get a negative times a negative, which is a positive. And this thing says, I would like to know numbers that are 0 or negative. And what happened? It doesn't work. It's weird. So is there no solution? There's one solution because it said 0 itself was okay. So this is an outlier. Please understand that if you have a question that is an inequality, then your answer should be an inequality. Yeah. No, because what would make this thing go to 0 would positive 4 would make it go to 0, right? Because 4 minus 4. So generally speaking, I will fry you for having a problem that is an inequality and telling me that the answer is an equality. But this is the one time that that actually happens because it just hit dead on perfect. Because you know what it actually looks like? Is it's a parabola that goes like this. And what do you know about that parabola, everybody? It never went below, did it? So there you go. Now, I'm going to share something with you that you actually don't really need to know, but I kind of want you to appreciate it. So do we have the ability to solve quadratics? We could complete the square. We could factor. We could do quadratic formula. We have all these cool tricks, right? Well, what happens when you go to our friend the cubic? Now, see up here? I solved a cubic, but I solved it because I could factor it and get a quadratic. But these are both uglier. Well, there's this guy named Cardano. He was an Italian mathematician, Cardano. lived way back in the time, and Cardano was studying a problem. I could actually even show you the problem he was studying. And Cardano came out with this. Cardano's equation was to look something like this. Now, by the way, there's another whole page where he took the bigger problem and could make every equation that's a cubic into something that looks a little bit smaller. But if you look at this, does that look a little ugly? And then, by the way, he had to keep going and then solve some part of this and plug it into this, and then take this and plug it into something else to get all the way down to here. Oh my goodness, does that look fun? No. In fact, there's another one that allows us to solve fourth degree equations. It's, by the way, even worse. I did it once in a history of math class. Because what most mathematicians now say is, you know what, that's just not worth the pain. That's way too much pain for what we get out of it. So what we have decided to do is kind of fake it. So here's what's going to happen. We're going to either take out Desmos, or we're going to take out a graphing calculator, and we're going to see what happens. Okay, now, I hope you guys, do you guys know what a cubic ought to look like? The cubic ought to have that kind of shape that's like an S curve, right? So, do you guys see an S curve? I don't, but the reason I don't see that S curve is because there was that plus 21 in that problem that sent it up a little bit higher. So I'm just going to make my window a little bit higher here so I can see it. Do you see the S curve now? Ah, so here's the deal, everybody. Because it's a cubic, we are not going to do hard work. We're going to do easy work. I want this cubic to be above 0. So do you guys see where it is above 0? So I need to find out what is this point right here. Now in Desmos, if you graph this in Desmos, you'll just be able to click right on the spot where it hits and it's going to tell you. You can't use Desmos on your test though. So we're going to go this way. So I do want you to see this. So I need to find this spot, so I hit calculate 0, which is number 2. You see it? Now the directions my calculator says is it says, can you please move to the left of that 0? So I'm going to move over to the left. Notice I'm hitting the left arrow until I have passed it on the left, and I hit enter. Then what does my calculator say? Go ahead and move over to the right. So I'm going to move over to the right until I pass it. And I hit enter twice. And it says, hey, you got 0 at negative 2.038. So this answer is everything from negative 2.038 until when? Till infinity, and we're out. Now, when do you get to chicken out and not do real work and just let your calculator do it for you? If it is a 3rd degree or a 4th degree, what about a 5th degree? Yep. You only have to do problems that are degree 1 or 2. Yay. Now, why did I actually do this one? Well, it was a cubic, but it was a factorable one, and I could make it get nicer, okay? Okay, and so for the last 5 minutes, sorry that I'm talking a lot, let's get back to here, let's go through those. I want to come up with a problem that is always, always, always true. So you see that number line we had? I want something that is always true, so check this out. Would this always be true? Would you guys buy that? If I square something, what's the lowest value I would get? Couldn't I get 0? Yeah, it's gonna work. So would this have all real solutions? Okay, try this one. What about if I said x squared has to be below negative 4? When would that be true? Well, that ain't gonna happen, right? So, I could come up with one that's 100% true. Now, could I pick a different number than negative 4? Yeah, any negative would work. Some people would say, well, I like this one. I wanted negative x squared, and I wanted negative x squared, which goes down to be bigger than positive 3. Well, that's the same thing. You know, there's a lot of answers. There's an infinite number of solutions. Anybody have an idea for this one that has exactly one? We saw one on the front side. I'm going to just go x squared is less than or equal to 0. Will x squared ever actually be less than 0? No, but will it ever be equal to 0? Heck yeah. Now, check this one out. I want an answer right in here. So what I'm going to do is I'm going to pick the two factors, x plus 5 and x minus 5. Now think about it. If I were to graph that, it would look like this. So what portion of the graph am I actually wanting in this story? If I graphed this, I would get this upsloping parabola. I want everything that's in between, but where is this little dotted graph? Isn't it under the axis? Under the axis is what? Negative, isn't it? Now I have an error. Can you guys tell me what my little teeny error is? See the square brackets? This. Oh, I need. Now, why did I go less than? Because it was underneath. Whereas in this problem right here, I'm saying I want values, think about it, that are above the graph. So I want x plus 1 again. I want x minus 4 again. But where would I want this one to be? Do I want above the axis or below the axis? Look at where the shading is. I want above, so how would I compare that to if I want above? Greater than. Now, do I want the equal to this time? No, we're going to say a big fat negative to that equality this time. Now, number 14, I didn't quite get to. We'll have to kind of pick that up next time. But your homework is just to kind of finish up as much of that as you can. So you kind of have two things, which is the prerequisite review, which we already did about half of. And then this thing, which we've done probably 80% of. So you just have a couple extra questions to do there. And we will pick it up later. And Maisie, just let me know if you need any help. I'm going to hit stop on